3, go.
Action.
All right, so we have a variety of tools here. They're all multimeters, and they will be set up for particular cases. So we have these 3 multimeters here. These 2 are basically the same, although this one has been mishandled, shall I say, and can no longer read current. So the ones that no longer read current, we take these rubber backing off. So presumably this multimeter should be able to measure current. Now, a word about multimeters. They are able to measure resistance, current, or amps, and they also measure voltage. And that's typically what we use them for. Some of these guys can actually measure more than that. Particularly, this particular guy can measure such things as the characteristic associated with silicon devices, or with, I think this is for vacuum tubes. They are turned on and off by different methods. So if you guys could take a look at this here, this is in the off state, and you can see that the needle, if you will, is pointing to this little open circle. And if you continue watching it, if I move it over here, then you get some digits appearing in the LCD's display. On the other hand, if you guys look over to this multimeter, you see that there's an on-off switch, and this selector is set for DC in amperes, and if I turn it on, you'll see that a number appears. Okay, so we'll turn it back off again. The other thing that we have, or some other things that we have here, we have a let's see, forget what these things are called. It's basically a prototyping board, and the prototyping board has this particular characteristic for this particular set. Other prototyping boards have different other characteristics. But in general, they all have a similar characteristic in the sense that all of these we call this a row and this a column, just to get us all straight. All of these spots here, when I put this wire in, this wire is now attached. It has now 0 resistance to everything else on that row. The same is true over here. All of these guys are connected together and have 0 resistance. So they're all tied together. Now, on the other hand, this row is not tied to that row. And none of these different rows for the same column. So this row is different than that row. Okay? So if I have this wire here and push it in, and it's connected down to this one, then these 2 are connecting this top row labeled 1, and then this one is labeled like 17 or something, if you can see the numbers along here. On the other hand, I can connect this over onto this side if I so desire, and this is now connecting this row here with that row up there. Now, one thing that makes this prototype board a little bit different than ones I've been used to is on this column here, these 2 columns here, one is indicated in red and the other is indicated in blue. And these, I believe, all of this entire column, each one of these columns is tied together. And so what you would suspect to be the case is you would want to connect this to this here and this one over to here, and now this gives you access to these entire columns. And what you might consider useful for this is this would be the plus side on a power supply, and that would be the negative side or ground, and then you have access to the plus side plus 5 volts or 10 volts on this side, and ground for everything else that you can connect to with different wires. Okay, so that's a useful sort of thing to keep track of. So let's see if we can actually test to see if this is the case. If I do something like this, now I have two wires that are now connected to over here, and if I have a cable like so, let's see, I'll use this one. So right now, theoretically, I have this cable going to these two ports, going to the blue and the green cable, going through the red and the blue column, and then going to each one of these. I would suspect that if I look at the, the resistance across those, that I would get 0. So let's go and verify that. And we'll take a look at what this thing is. The multimeter needs to be set to registering resistance. So I'm flipping the selector over to here, to this little area here, which shows the ohm symbol. So the omega symbol there. And we'll turn it on and we'll see if we get 0. And as you see, we get something really small. Okay, so my theory was true. Okay, I'm happy about that. All right, so let's turn that off. And so that is what makes this protoboard kind of nice.
I have a question.
Yeah, ask.
For this one, where you said you put it in ohms, right?
Yes.
Does it matter which one of those you put it in, or?
Yes, you would want to put it into an ohm setting such that you can read the value. So what do I mean by that? As you can see, I'm going from 200 up to 2,000. Does that say 2,000K or, yeah, 2,000K. So that's the amount of resistance I can register. And if I turn it on to one of these things, you'll see a 1 here, and that basically is saying that I'm, basically it's over scale. So that I would expect that because I have infinite resistance here. Now here in this case, I should get 0 resistance because I'm attaching the two probes to each other. And this is registering half an ohm of resistance. Now, notice what happens if I increase the selector dial up to a larger value. It's going to move the decimal point over, but also I'm not going to be able to read anything. Okay, so the decimal point moves, but this is now registering 0.00 K. Right, so the largest number I can read on this is 20K, which means there would be a 2 appearing in that spot right there where you don't see anything. Okay, and the same sort of thing applies for the rest of these numbers. All right, so if I now take a resistor, just any old resistor here, and if I was clever and knew my resistor codes, then I could determine what the resistance is just from the color coordination, or the color code on here.
That's universal?
Yes, that code is universal. And here, this looks like it's a 1,000, 1K ohm resistor here. Okay.
And how did you know that unit was in thousands?
Because it's at the selector is set for 20K.
What if you put it down to the lowest setting?
Then this is now at the 2,000 is the highest value it would read, and now it's registering 1,007 ohms. Okay, so that's really pretty close to 1K ohm. And if I did it at 200, you see that it's over scale, and then this last one shows something, but okay, now I can go the other way, and here is, the 200 would be in that spot right there, and you can see that, it's registering 1, and over here this would be, minimum scale. So
Going back to the question that we asked before, does it matter if where your blue cable, where your black cable is, or where your red cable is?
Well, that depends upon what you're really asking. So if I did this, and flipped it over here like so, then that doesn't matter. Okay, I can do that without any worry about what's going to happen in the unit. Okay, measuring resistance or voltage typically is not a problem with these devices. Measuring current, you do have to be careful because you can put too much current through one of these devices and blow out the fuse. But if you're reading or measuring resistance or voltage, that's not an issue.
So if you're measuring current, how would the setup be?
Okay, so another thing to answer the question by is normally if you look at here, you see that this selected, this socket here says COM, okay, it's for common. Sometimes it's, this little symbol here is ground, and normally one of your cables is going to be associated with that. And typically we put in cables, black is normally, used for your ground cable, and red for your power cable. Is it really strictly supposed to be that way? No, it doesn't matter. But when you get a lot of cables floating around, it does help to make things easier to figure out. All right, so now for this particular setup, I'm going to be measuring ohms, and the color of the cable doesn't matter, but if you notice here and here that the common is utilized as well as volts, ohms, and milliamps. Okay, so for this particular multimeter, if I was registering voltage, current, or resistance, I'm going to be using these two. And I'd be turning it on and off like so. If I'm not using it, I'm going to keep it off. All right? All right, now these are a little bit different in that you see I now have, instead of 3, I have 4 spigots. And this one has 3, and on both of these, you see that there's a spigot here for 10 amps of DC there, and I have 10 amps of DC there. Okay? So when I go to a higher current, I need to have a different fuse, and so I'm going to be selecting on it. Okay? So 10 amps is a lot of current. Okay? Normally we want to keep things much lower than that. All right, let's see. Okay, now if I wanted to read we already know what the resistance of this guy is. So let me just flip this over here, and we should be getting the same value, right? Which we do. Okay. Okay, turned it off. All right. Okay, so one of the requests that's going to be asked, that's going to be asked on, that we want you to learn in this class is how to use a multimeter. So I've shown you how to do the multimeter on the resistance. Okay. So, always you measure it several times, right? How many times?
At least 3.
At least 3. Okay. Now, chances are with these sorts of things, you're going to get the same value, right? And so the lowest, the error on your value is the best measurement you can make, which is probably the lowest digit on the multimeter. Okay, that would be acceptable. Okay. All right. Okay, the next setup that we want to do is measure current and voltage. And what we want to do there is, let's use this guy, and not use this one. And we're going to set this one up to measure current. And we're going to set up this one to measure voltage. So let's see, current, there's ohms, there's my current setting, so I want to do something like that. And I need a couple of cables, so we're going to use, let's see, we're going to need these two, and we want, I'll take this one, and we'll do this one. And this is going to be at milliamps because I'm purposely going to measure current. And the circuit that I want to build is just going to be something that looks like this. So I'm going to take a power supply, that's variable, which is this guy here. And let's turn this guy off just to keep it off. And then I'm going to have a resistor, and I'm going to want to measure the current. So I have an ammeter there, and then I'm going to measure the voltage across the whole thing. Now, one of the things that you might be concerned about is whether this, all these, this represents a probe, that represents a probe. There's going to be a probe here and here, and there's going to be a resistor, and then there's going to, there's going to be cables here, right? But you might be worried that if I measure the voltage across this, that it's going to be different than if I read the voltage across here. Don't worry about that. It shouldn't be any different, okay? The amount of resistance across this ammeter is supposed to be very small. So if I have any voltage difference across here, that's when I blow the fuse. Okay, that's why these things go bad like this. So what I want to do to preclude that is create the circuit without any power, and then verify that I got all the pieces in there, and then turn it on. Okay, so that's what I'm going to do. So I'm going to put the resistor across a couple of these guys. And it doesn't really matter where, just someplace. Could be this way, it could also be that way. Maybe this way is a little bit easier to access.
Low battery.
All right, so I have this power supply is off, and I have the plus side going to here. And I'm going to attach those two rows together. So the green is now attached to one side of the resistor. So this part of the circuit is now created. So I'm going from the positive side of the power supply over to through here to here, and the row, this entire row is now energized. It's the same right there. So I'm going to one side of the resistor. So that's knocked off. And then the other thing I want to do is from this location, I want to go to a voltmeter. So can't get that out of there. So I want to go to a voltmeter. Okay, and so how do I do that? So let's see. One of the things I could do is just attach this guy to there. So this goes to one side of the voltmeter. Oh, but I want to use this for the current. So let's use this one. right? Because this guy can register current. So I'm going to go right across here like so. And that goes to the plus side there. And then the negative side wants to go to the other side. Okay, so this part of the circuit is done. And what I want to go from is one side of the resistor to the other side of, one side of the amp meter. Okay, so I go from, I can go like this. Okay, so now this part of the circuit is done. Okay, so one of the things I do is I have a schematic and I start knocking off various things on my circuit. Okay, now on the other side of the ammeter, I want to go to the voltmeter. Okay, which is this one here. So I'm going to take this guy out and put this one here. Okay, so one side of the ammeter goes to one side of the voltmeter, right? So I got this part of the circuit done. And then on the other side, right? So all this is connected together. So if I wanted to, I could either do, well, basically I got to get to the other side of the power supply. So I can either go here to there, and I'd rather have a different connector than that.
Or you could put in the AND meter, right?
No, I need to come over here. Oh,
So
I know
I'm
what I
saying
can do. I can do this, and I can do that.
What if you clicked it to the AND meter?
I could do that too.
That's the same thing, right?
That would be the same thing, right? Because they're tied together. But this cable doesn't seem to go all the way, want to go all the way over there. It sort of would be kind of messy. And in this sense, there aren't very many cables here, but it sort of makes it more compact.
I was just asking because of the schematic. I was just trying to understand.
That's fine, that's fine. Yeah, that's perfectly, it's a good reason. Okay, so now I'm going to turn these guys on. Okay, so this is my voltage, right? And I'm pretty confident that this is right? Because I did it, you know, piece by piece, and I marked these things off. Yeah.
What about the blue wires?
The blue wire is not doing anything.
It doesn't have to?
It doesn't have to.
Okay.
Why not?
Because I'm not using it as part of the circuit. So I could have also, to make it equivalent, I could have taken this off. Come on out, you. And connected it to there, and that would have been equivalent.
Okay.
All right. So you use these things to sort of spread things out to make it easier to visualize what this is doing. Okay. So this is just a pictorial representation of what you got there. And as you can see, if I had some more things to measure here, or if I had more components, it's going to get kind of messy. Okay, I won't be able to get to things, and then that's why I spread it out. So I really don't need to here. All right, so this is going to be measuring voltage. So let's put it on the voltage setting. And I'm going to put it from, you know, at the 20 volt setting. So the maximum voltage it's going to want to read is 20. And then over here, I'm going to be measuring current. So that's going to be down here, and I'm going to probably be about there. So let's see, this was, if I recall correctly, I think we said this was 1,000 ohms?
Yeah.
Okay, so if we do, the current that we should expect is, let's say 10 volts divided by 1,000. So that's going to be 1 over 100 amps, right? So that we should be getting, you know, 0.01 amps or 10 milliamps, right? So we should be getting, that should be registering 10 if we get 10 milliamps if this is at 10. Okay, so
you put it at 10?
yeah, I sort of put this thing at 10, but this scale is sort of,
Off.
you know, yeah, it's off. You don't, you know, some axe murderer could have done it or something. But what you want to get is this is going to be true, okay? And that's going to be true. So we should be getting 10 across the board. And look at that, you know, that's pretty close. We, you know, if we wanted to get up to 10, we could get up to 10. Now, this is just one measurement of current and voltage, okay? And we want to, this is one of the things I want you to do for tomorrow, or whenever you make these measurements, is we want to prove Ohm's law, right? Which is V is equal to IR, right? And so you're going to take a variety of measurements. Okay, here we are at roughly 10. Then we're going to go down to, you know, 8, and then 7, and, you know, whatever. And you go down, and then you come back up and take some more measurements, right? Because at you want to take 3 measurements at all the same values, roughly, right? You know, you want to take 3 measurements so you get an error on it. Okay, any questions? Yeah.
Does this green cable have to be connected in the row, or can it also be connected in the column?
No, it has to be in the row.
Okay.
Okay. Remember, all these things in the same row are tied together.
Okay.
Only
Okay.
the 5, right? Only the 5.
Yeah, only these 5. Okay.
Okay.
This 5 is going to be different than this 5, which is going to be different than that 5 and that 5. And none of the columns are attached to each other. Okay. But the blue on this side and the blue over here and the red over here, all this entire column is tied together. And this entire column is tied together. Okay? Yes. Good question. Okay.
And then, sorry, I have another question. Would this be the resistors in parallel?
No, that's in series.
That's right. They're in series.
They're in the same.
We got one going to, these two are attached together,
Oh, yeah.
right? This one is now attached to this one. In the circuit will look like one resistor and then another resistor.
Okay.
Okay? And if I drew a picture, it would be something that looked like this. Right?
Okay. And how could it be parallel?
How could it be parallel?
Yes.
Parallel would be if I did something like that. So the ends are now, so that would be a parallel circuit.
Okay. And then this would have to be here?
Well, if
If
that's what the
voltage.
circuit required.
Okay.
But these two resistors are now in parallel.
Okay. Got it.
Okay, now any circuit is going to be made up of elements that are in series and elements that are in parallel. Okay, so as an example, in this circuit here, the resistor and the ammeter are in series. The voltmeter is in parallel with the ammeter and the voltmeter. I mean, with the ammeter and the resistor. And it's also in parallel with the power supply. Okay.
Okay.
Any other questions?
So for this one, right, V equals IR, we're always gonna measure the resistor first before we do anything?
It doesn't matter when you measure the resistor. You can measure the,
I mean, like in order to get calculations, right?
for tomorrow, the purpose is to show how to utilize a multimeter. And so I want you to measure current, voltage, and resistance. So, you know, basically I'm going to be giving you a resistor. You're going to be making up a circuit that looks like this.
Oh, we get to make our own circuit?
Yes.
That. We don't make it out, right?
I'm going to be giving you the piece parts, just like you gave me the piece parts.
Okay.
Okay?
So if we
And
do this exact same one, is that okay?
essentially similar, yeah. You know me, I'm not going to give you a straight answer. Okay.
I don't know.
So you can measure the resistance of the resistor afterwards. I would suggest doing it beforehand because then you can make the calculation like this. Okay, you could make this calculation.
I'm coming behind.
Okay?
Okay.
All right, cool guys.
Wait,